Hello, and welcome to my account of the Good Friday earthquake of 1964 in Alaska. At 5:36 a.m. on March 27, 1964 in Alaska, this portion of the Earth experienced a shocking event. Small earthquakes are fairly common in this region. In fact, Alaska experiences an average of 60 earthquakes per day, which typically last for a few seconds to 1 minute. However, the Good Friday earthquake was not a fairly common earthquake. After roughly 4.5 minutes, roads sank, houses pulled apart, and railroad tracks warped as the Earth was shifted by an earthquake of magnitude 9.2, the largest ever recorded earthquake in American history and the second largest recorded earthquake worldwide. The impact of this event didn't end in these few minutes. The earthquake also triggered a major tsunami, with damage ranging from the Kodiak Islands all the way to Northern California. Survivors were forced to flee to higher ground as their homes were flooded and destroyed below them. Thousands of aftershocks followed for up to 3 weeks after the initial impact. By midnight, a total of 131 people had died. Eventually, a total of $15 million in damages would be reported. The earthquake, tsunami, and aftershocks produced countless water, sewer, and gas line breaks. There was widespread telephone and electrical failure, roads were torn in half, highways were damaged by flooding, and many houses, buildings, and other infrastructure sustained major damage because they weren't designed to be resistant to earthquakes. This event had severe impacts on many individual towns, villages, and pieces of infrastructure. Most of the coastal towns in the Prince William Sound were heavily damaged, and the $1 million bridge crossing the Copper River collapsed. Some areas, such as Girdwood and Portage, dropped in elevation, which changed the high tide mark in these places and required reconstruction to raise highways and other pieces of infrastructure above this new high tide mark. In the town of Valdez, 30 people died in the port due to an underwater landslide that caused the collapse of the town's harbor and docks. Many residents of Valdez had to live in roadhouses for a few weeks after the earthquake, and the ground under the town became unstable, which eventually required it to be completely relocated after 3 years. In the village of Chenega, 23 people were killed, which was about 34% of the village's entire population. Since many people in coastal areas had to flee to higher ground to survive the tsunamis, this also created a precedent for people in other coastal areas to move to higher ground at the first signs of a tsunami in their area. As a result of this earthquake, some areas of land rose and others sank. Areas of coastline near Kodiak and Hinchinbrook Island were permanently raised by 30 feet, while other areas, like Girdwood and Portage, dropped by up to 8 feet. Large sections of the seafloor were uplifted, and a portion of the coast moved 50 feet towards the ocean. This change in the topography of the landscape affected many organisms and habitats. In an example of the geosphere interacting with the biosphere, many coastal marshlands and forests, as well as other freshwater reservoirs, were destroyed by salt water. This then further impacted the biosphere as moose and migratory birds that relied on these habitats for food struggled to survive. The geosphere and hydrosphere also affected the biosphere when salmon spawning areas were affected by saltwater and sediment from landslides. The hydrosphere and geosphere also affected the biosphere when avalanches produced by the earthquake affected goats, sheep, deer, and moose by directly killing them and destroying their habitat. What could have occurred to produce such a massive event? Scientists eventually concluded that this earthquake occurred along a subduction zone on the Pacific Plate, as Alaska's southern coastline marks where the Pacific Plate moves below the North American Plate. The fault where the earthquake occurred sloped deep below the continent, producing a subduction zone. Tectonic plates typically move very slowly, but in this case, the fault slipped and the Pacific Plate moved up to 60 feet at once. This resulted in a megathrust earthquake, which is an earthquake that occurs directly along a subduction zone and creates a sudden, exaggerated motion that enables the occurrence of extremely large earthquakes, such as this one. When this earthquake occurred in 1964, plate tectonic theory was still relatively new. However, plate tectonics is now a fairly well-documented theory, partially because the Good Friday earthquake was the first observed physical proof that scientists had of the effects of plate tectonics. This changed their understanding of Earth processes and resulted in the creation of new systems and policies to enable people to more effectively respond to and recover from earthquakes. A broad earthquake monitoring system was established to help predict the occurrence and severity of future earthquakes, and engineers developed earthquake-resistant structures to reduce future damage to infrastructure. The tsunamis produced by this earthquake also allowed scientists to discover that tsunamis caused by earthquakes can actually occur quite far from the epicenter of the earthquake itself, which led to the creation of the Pacific Tsunami Warning Center, which warns people when a tsunami is possible in their area. The response to the Good Friday earthquake marks major developments in the scientific understanding of plate tectonics, as well as the way in which scientific findings can impact public policy in ways that enable us to more effectively predict, prepare for, and respond to disasters.